6.4, we're going to talk about similar and congruent figures. Now, obviously the word congruent we have talked about in the past. Congruent means the same or equal. Okay, similar is like the word equivalent. In other words, if we had the fraction 3 over 4 and 75 over 100, those two fractions are equivalent. They don't have the same numbers, but they are equivalent. Okay, similar triangles is, for example, I have a triangle that looks like this, and then I have a triangle that looks like that. Okay, these two triangles would be similar if the ratio of two sides are the same or equivalent. Okay, so in other words, you do the ratio of two of the sides. Let's say, for example, this was 3, 4, and 5, and this was 6, 8, and 10. Okay, it doesn't matter if it's inches, meters, centimeters, millimeters, it doesn't matter. Okay, as you look at those two triangles, what do you notice about the different lengths? Like the length of, we'll call this A, and the length of B. If you're going from A to B, not from B to A, from A to B, what are they? Right. Yeah, they're twice as big. Okay, 1 to 3. This side here is a 3. This side's a 6. This side's a 4. This side's an 8. This side's a 5. That side's a 10. From A to B, it would basically be twice the length of A to get to B. So it's all the same. Okay, and so that's an example of a similar triangle. The triangle is similar. It's just the legs of the triangle are shorter than the other side, than the other one. Okay, and then there's congruent, where if you had two congruent triangles, well then they're just exactly the same. Okay, every aspect of them is exactly the same. All right, now that's what congruent is. Now, they don't have to be necessarily right triangles. Okay, those are all right triangles, but it doesn't have to be necessarily a right triangle. It can be any figure. It could be a rectangle. Okay, it could be obviously a square, but you could have, for example, you could have this. Okay, you could have that square, and then you have another square, right beside it like that. Now, those could be similar. They're obviously not congruent because they're not exactly the same height or anything like that. They could be congruent, but they don't necessarily have to be. They could be similar, but maybe not. Okay. For example, let's say that they said this side was 4. Okay, and they said this side is 9. Obviously, hang on. I'm going to make that 1, since it's obviously not 9, since it's smaller than the other one. Okay, 4 and 1. Well, the bottom line is that if one side is 4, and then the other square it's 1, and they do this, like that, then they've got to be similar. Okay? What the little tick marks here on this first one mean is those sides are congruent where that line is. Okay? The reason we use 2 over here is because if you use 1, then you're saying that it's the same, these two are the same when it's posted together like this. So we do 2 marks. The 2 marks on each side means all those sides are congruent for that specific square. Okay, if it was 1 tick mark, then that would say, yeah, they're the same, even though they don't look the same. Okay, so if there's only one measurement and then they have the tick marks, we have to assume that all the sides are exactly the same size. Okay? Now, let's look at an example. Let's say I had these two triangles. This is triangle A, B, C, and it's 4, 5, and 3 centimeters. Okay, and then we have whoops, that's not that. Hang on. Erase that part. Come straight down. Okay, and over here we had 4.5, 7.5 centimeters, and 6 centimeters. And this is E, F, and D. Okay? All right. What we want to talk about here is two different things. First of all, corresponding angles. Okay, and corresponding sides. Okay, if the triangles are similar, okay, if they are similar, and here's how they're going to show you that they're similar. They're going to put this with it, triangle ABC is similar, that's what the little S is, similar to triangle DEF. Okay? That's what they mean by similar, is the little, you know, whatever you want to say, upside down. It's not really upside down, sideways S, I guess. Okay? And what they're saying is this. The order that they list these letters in is very important. What it is saying is that A here and D there are the same point. Okay? B here and E here, so these two are the same point. And their similarity in the triangle, okay, those points are the same, and then so is F and C are the same. Okay? So, then as we are looking for corresponding sides, so basically what did they do to the triangle? What did they do to the triangle? From triangle A, B, C to E, F, D, what did they do to the triangle? I mean, is it sitting the same? Is it? Obviously, it's another way. What's the other way? What did they do to it is what I'm asking you. Right, they flipped it. They flipped it. They flipped it, but they also did what? They made it bigger, and they flipped it up on the vertical, but they also flipped it on the horizontal. In other words, this side right here is facing this way, but it's facing this way here. Okay? So they not only flipped it like this, they turned it like that, but then they rotated it horizontally as well. Okay? And so as you look at those two, then they also in the book have this as a 90-degree angle. Okay, remember 90-degree angle, when they have the small square in the angle, that means that it's a 90-degree angle. Okay. Now, what they want us to do is they want us to list the corresponding sides. In other words, a side on this triangle, in other words, side BC on this triangle is what? Which one is it on the bigger triangle? FE. Yeah. So there's your first one. BC, line segment BC, and line segment FE. That's your first corresponding side. Okay, the second one, and once again, these could be in any order. They don't have to be in, the pairs don't have to be in this specific order. The second one would be BA, or AB, line segment AB, and what? ED or DE. We'll just keep it alphabetically correct. Okay? Then your last set is what? We have AB, we have BC, so AC, and what? FD or DF. Okay? Now, what you will also understand, and what you also look at is this. Okay, we said BC, which is right here, and EF, which is right here. Okay, they also fall together in the lettering. That's why the lettering, they've put the letter in order of their similarity. Okay, on the other triangle. Happens to be in alphabetical order, but you know that's not always the case. Okay, so those are your corresponding sides. The corresponding angles, well, it would be angle A and angle D. Okay, another set is angle B and angle E. And the third and final pair would be angle C and angle F. It's an angle sign. It almost looks like an inequality sign, but it's like that right there. Okay, so that's the corresponding angles along with the corresponding sides, and realistically, and really, you don't even have to work. You really don't even have to have the figures. Okay, you can just go by what is right here. Triangle ABC. So that's a point, or that's an angle, that's an angle, that's an angle, and it corresponds to that angle, and that angle. So you really don't even have to have the figure. But that's how you figure the corresponding sides and corresponding angles. Now, I also, since they're similar, want to know the ratio of their lengths. Okay, the ratio of their lengths method here. Yeah. Okay. To figure the ratio of their lengths, here's what you're going to do. You're going to look at the corresponding sides. For example, if we look at line segment BC and line segment FE, what is the length of BC? So I'm going to take BC over EF. Okay? Another reason why you need to put those lines in there now, because you got a bunch of them in there now. All right. Now, what is the measurement of BC? 3 centimeters. So I have 3 on top, and what is EF? EF is 4.5. Do what? Yes. Yeah, I'm looking at the ratio of the two sides that are similar. So you do the same thing here. That's what I'm saying. You could use any of these. If you had line segment AB over line segment DE, well, AB is what? 4 over 7.5. No, excuse me, 6. 4 over 6 reduces to what? 2 over 3. Now I'm getting somewhere with this. I just want to show you can use any of the sides. And the last size was AC over DF. AC was 5. DF is 7.5. Okay. Now let's look at those ratios. Those are the ratio of the similar sides. Okay. As we looked at the second one was 2/3. Okay. Well, when I take a fraction 3 over 4.5, I can't have decimals in my fractions. So what I'm going to do is this. Move that decimal out one place. But what I do on the bottom, I must do on the top. Okay? And so that's 30 over 45. Well, what does 30 over 45 reduce to? Huh? 6 over 9, which reduces to what? 2 over 3. So this one and that one match up. Okay, I'll show you the other one does too. If we take 5 over 7.5, we can't have a decimal in our fraction, so we move it once, so that's 50 over 75. Well, I can divide that by 25 over 25, and that's 2/3. So all three of your ratios are 2/3. So that even proves, not that we were supposed to prove it, they just wanted one of those answers, 2/3, that proves that the triangles are similar, okay, because each one of their ratios of the corresponding sides is the same, okay. So the answer to the problem would be 2/3. That's the ratio of their lengths, okay. The ratio is 2/3. That would be, now, a lot of times, yeah, obviously if you were comparing the larger triangle to the smaller triangle, then the ratio would be 3:2, or 3 over 2, okay? But we're comparing this first triangle to the second triangle, okay? So that's your corresponding angles, that's your corresponding sides, and that's your ratio of length. Now, the other question that they ask you is, what is the measurement of angle B? What is the measurement of this angle right here? No, measurement of the angle, like 10 degrees, 20 degrees, 90 degrees. Why? How do we know that? How do we know that? Huh? How do we know that it's 90 degrees? There's a square there? There's no square there. Then why is it 95? Why is it 90? Okay, we just said in our answers over here, we just said that angle B and angle E are corresponding angles. Corresponding angles have to be the same. They have to be the same measurement. So if this one, E, is 90 degrees, then that's what B has to be. B has to be 90 degrees. So yes, it is 90 degrees, but you didn't know why it was 90 degrees. You couldn't prove it to me that it was 90 degrees. Okay? Now, so that's how we figure corresponding sides, corresponding angles, and corresponding measurements. Now, let me just show you something real quick. I'll make an arrow over there to show you that's over there. If I did this, I did square ABCD is similar to square EFG and H. And I just did that right there. I said they're similar. Square ABCD is similar to square EFGH. Okay? Well, what would the corresponding angles be? So if I want you to list the corresponding angles, and this is where I think some of you were asleep a while ago and you weren't really paying attention to what I said. That's why I'm doing another example. I'm not going to draw the picture. What are the corresponding angles for square ABCD that's similar to square EFGH? What are the corresponding angles? Haley. A big square and a little square. What? We're not talking about the three bears. We're not talking about, it's too hot, it's too cold, just right. We're talking about, I want to know the corresponding angles of those two figures. And I said it a while ago, but y'all aren't paying attention. That's why I'm re-saying it and redoing it. How many angles are in a square? Okay, then there has to be 4 corresponding angles if they're similar. Laney, what do you think? Right. Angle A and angle E, angle B and angle F, angle C and angle G, angle D and angle H. I said a while ago, the order the letters are presented in is important. It tells you which ones are the same on each figure. Okay? That's what I said. All right, your homework. We'll finish up the rest of the second half of this. We're going to go 6.4, 1 through 9. Okay? That is due tomorrow. You may go.